Hi ladies and gentlemen, today I will be talking about CNC router in very simple terms. Now let us see what is the agenda, what is the content for today's talk. So first we will look at the introduction, then very briefly we will be talk about the history of the CNC router and production environment, and we'll talk about the G code programming in NC code generation, and then how the CNC router works and the benefits of CNC router, and then the basic type of CNC routers, and about router beats and maintenance and safety, and conclusion. So let us see what is the first term is what was this introduction to CNC router. CNC router what is CNC means. First we will see what is CNC. CNC is computer numerical control. Computer numerical control. So what is it is both connected with computer. In computer what it does is that it creates code, that is the NC code, that is the numerical code, what we call the NC code, and that NC code file is fed into the CNC machine, what we call as to the CNC machine controller. The CNC controller understand the file or read the file and move according to the instruction from the NC code. So computer does the job of creating the NC codes according to the design file supplied, and whatever the way we have programmed the in the CAM software, that is whether what all the tool we have used and how much depth of cut we have given and various other machining parameters and tool parameters accordingly, and according to the design it will create a tool path. That the created code tool path will be converted or post-processed according to the controller's capability, the controller language, then fed into the controller to read that file and to make the machine run. So that is that's why computer numerical and control means. So in simple terms, computer controller that reads coded instructions and drive a machine tool. That is what CNC machine is. So CNC machine is, then definitely is an automated one, and so you can have faster production and maintain consistent high quality. You can expect a high quality from CNC machines. So now we will see the history. In history terms, the general CNC machine itself, the NC code machine, first developed in 1940 by John T. Parsons at MIT, developed the first NC machine, that is numerical control machine, where you don't have the computer. The computer came later, so it becomes CNC. So in NC machine what was there? It is a hardwired thing. So whatever the programming we are given, it will be done in the hardware. It is in the hardware of the machine. It will be the program is embedded, or you will use external device like cards, where you can punch the cards and it will read the punched cards like that. So it's a hardwired programming only. So it is very not so flexible to change the programming like now we do in CNC, where it is the computers enabled software programming. You have a lot of flexibility. So the computer came into place. So first applied this technology, that is computer numerical control, this computer assisted programming, first applied in metalworking, later adapted to woodworking and other applications. Entry of CNC brought radical change in manufacturing industry. As it is any other machine, the CNC first had a big role play in metal working industry. Later gone to a low core areas like woodworking, sign making and all those things. So it has a major impact on various industries. And production by CNC machine enabled cheap and high quality goods and started available, because you have the better production capacity. And you can have also with you are able to produce high quality products. So the high quality goods started available, and also high volume of production. Because of high volume production, it also we can reduce the production cost, and we could able to get much cheaper products. So CNC automation reduced the frequency of errors, and one of the plus point is that and it reduces the errors and more time for operators to the additional works, because in conventional things you have to be always supervising the machine to avoid the errors. Here you can put in an automatic mode, and you can do some other job by the time it finishes the work. So allowed a more flexibility in manufacturing process. So definitely this manufacturing process, you have more flexibility like that. You need not have you can you can do a number of jobs in the same machine itself. You need not to go a number of special purpose machine. It will, the same job can be done in a CNC machine just by changing the programs. So it's reduced time for changeover to produce different components. So this is the history, what way it has helped in the CNC machine, helped the industries. Now we look into the production environment. In production environment, how it works. Earlier, CNC machines, the CNC machines controlled from files, as I told earlier, and created manually or by CAD/CAM software. So you can do both manual programming and CAD/CAM programming. In CAM programming, you can use a computer to make the program. In manual programming, what you have to do, you have to calculate each tool's movement. Geometrically, you have to mathematical formula, you have to write like that. X, it has to go from one place to X direction, it has to go 200 mm, means X 200 mm, Y it has to go Y 500 mm, like that. We have to manually write the tool path direction, the tool path values we have to write down, and that we will put in a file, and that file can be read by the CNC controller, and this machine can run. That is the manual programming style. Or you can directly, instead of creating files, you can directly enter to the keyboard of the system to the controller panel, and that way also we can make it run. But mostly manual programming is helpful in simple geometries. If it is a very complex geometries, and especially 3D kind of geometry, writing manual programming is cumbersome process, and it is time taking, and it's almost impossible sometimes to write the programs. So we take the help of computer aided design as well as the computer aided manufacturing, where the first we will do the required designing. That is, the CAD becomes the basis of the CAM programming. Looking at the digital values, digital content of the CAD, we can create the whatever the information in the CAD will be taken into the for the CAM programming, and we will be giving an additional information also, the way we have to operate, and the kind of operations we have to do, like that milling, turning, or deep engraving, marking. All depend of different operations are available. So we can select different kinds of operations, as well as we can select different kinds of tools. We can give a different machine parameters, and also it's depend upon the capability of the machine, what your capability of the CNC machine, because CNC machine also would have made in with the different parameters. So we have to match with that parameters, looking at the end, that is which machine you are going to run the program. Accordingly we have to create the CAM program. So CNC machine program to perform many kind of machining operations, like I have already told. It can use for embossing, engraving, deep engraving, mill. We can call it in a different, like marking, drilling. We can call it in a different processes, different operations at different process. Like that, earlier we were doing slotting, shaping, and all this process we can do in one CNC machine itself. It can run, and another thing is that it can run hours and days without operator intervention, and there is no operator. Every time operator has to go and change something or look into. No, constant supervision is not required with the CNC machine. And some can even call operators, and even if he need not to be near to the CNC machine, he can work somewhere away from the CNC machine also, and there is some it in some machines that it can send out the messages to operator's mobile phone if there is any problems like tool breakage or power failure or coolant flow interruptions, etc. It will send a message to the mobile of the operator, and he can come back and attend the problem. So the production environment has been changed such a way. Next we will see that what is G code programming and NC code generation, like that. So what is there in the G code? So, okay, so in G code what is called functions in NC programming language. So what all that is the function, what function it is going to do, whether different functional, that is G code are letters. G codes are letters followed by numbers indicate a command. That is, if we are, it has a word like G, and we will call it as a preparatory code. It M, that is miscellaneous code, and like S for the spindle speed, F for the feed rate, like that. We have some preparatory codes, and when it followed by one number, it gives the right kind of command, like that. If X is X 100 means it has to move in X direction 100 unit, whether mm or inch, according to the program. So some of the typical words are O for the program number, N for sequence number, G for preparatory function, X for x-axis designation, okay, Y for y-axis, how much it has to move in y-axis, Z is Z designation, and radius designation, how much radius and how much feed rate, F. S is for spindle designation, and H is for tool length offset designation, and D for tool radius offset designation. Then T is for tool designation. That means if there is one word is there, like T is there, after that 01 means the first tool will engage, T is 02 means the second tool engage, like that. Then miscellaneous function, like that. M, whether the spindle has to on or off, the coolant has to on or off, like that. It all controls with one letter and followed by a number. Then I already explained about manual programming and CAM programming. In manual programming, these all G codes, we can write manually as per the given format of the controller of the machines. Different controller has a different format, and most of the things are almost in the same way. There will be some changes depending upon the controller, and this NC code we can feed into the machine to run for simple programs possible. So this is manual programming is okay with simple programs. And when the CAM programming is must for a complex geometry machining, here the program is generated automatically as per the CAD model and tool and machining parameters and method given during tool path creation. The different method we can adopt to create the tool path. Then the post process according to the controller of the machine specification in any CAD/CAM software. So we can do it with any CAD/CAM software. So we should have a post processor for that according to the controller of the software. So the direct file can be read in the controller and machine can move. Now nowadays most of the CAD/CAM software is compatible with the most of the CNC machine controllers. So now it becomes more flexible and more adaptable, more compatible. How CNC router work? So CNC router, already we explained about that. It can move in X. It can move in according to the NC code programs, like that. So generally the movement as per the CNC router is concerned, the movement the basic machine will have a 3-axis movement like X, Y, Z. X means in some machine it will be going left and right. It's a gantry type. In that the head, the tool head, that is spindle, will can move left, right. That can be X plus and X minus. Then the spindle can go front and back. That can be Y plus and Y minus, and the tool going up and down can be Z minus and Z plus. So this is the way the movement happens according to the program. NC code that is given, and spindle give the cutting power. So the movement as basically movement is the X, Y, Z. If it is a 4-axis 5, then rotary axis also coming, rotary movement also will be there. Now for the simple machine it will have X, Y, Z, the linear movements only. So 5-axis machine, there is another 2 more axis of movements, that is the rotary axis of movement will be there. Then this spindle is that is the main motor which gives the cutting power, in which the tool is fitted, that by spinning with especially for CNC router machine, it will be in very high RPMs. Okay, maybe like 18,000, 24,000, 40,000, 60,000 RPM, like that in the CNC router is available, compared to the CNC milling machine with a lesser RPM for metalworks. The profile movement is achieved by the program or the NC code given. So whatever the profile has to be, whether it is 2D profile or 3D profile, according to the profile we drawn as in the CAD, computer designing, according to that it can achieve the movement. So benefits of CNC router. What is the benefits of CNC router? It can work in many materials in almost endless variety of shapes. So shape is not a limit. It's a shape you can, whatever you can design in the CAD, you can create those shapes in CNC machine with some limitations according to the capability of the CNC router machine. Okay, and due to automation and quality and quantity is multiplied, and manual supervision for menial task is eliminated, labor costs are reduced, work no stop, no interruption in the work, and produce identical parts every time. If you given the same set of program, it will be creating the identical products only. So that is the it will be that's the repeatability will be the same. And skilled employees for programming and operation. The only place where you want the skilled people is that to create the designing as well as the programming for the operation. So operation also not that difficult, mainly the designing and programming is more difficult. Okay, so skilled employees are required there instead of the operational level. So skilled for manual work reduced, there is not much manual work as a CNC router is concerned. And also waste is reduced, a lot of material saving, and enhance productivity, creativity, in long run reduce cost. So it's also we have you can increase the productivity, also creativity, because of the design stage you can have a lot of flexibility in the designing to designing for manufacturing. So, okay, so in long run reduce cost, because the initial investment for the machine will be high, so in long run you can reduce the cost. So you can reap benefit from CNC router only if you have skills and training necessary to use it, especially in the designing stage and in the programming stage. You should have the right kind of skill, then the machine is very useful. Otherwise no point in investing lakhs of rupees in CNC router machine. If you are some people will just see the magic, okay, what all things we can do with the CNC router machine and all, they just jump into buying and investing the money in the machine. Later they will found they don't have the basic skills and knowledge to work with the machine. So especially happening in not in industrial to industry people, generally when it is adopted to non-core areas like furniture making, that's woodworking, stone carving, sign making and all. So where many machines are kept by the individuals, invested by the individual and running it. Okay, and now we will see the basic type of CNC router, how we can differentiate the different kinds of CNC router machine. What all way we can differentiate it, the benefits we have covered, then basic type of CNC router machines. So what all types of machines are there actually, what all way we can differentiate in many ways. So I have pointing here few categories depending upon the first is the depending upon the number of axes. So whether it is a 3-axis, 2-axis machine, 3-axis machine, 4-axis machine, 5-axis machine, and even there is more definition or like 6-axis and all. So it's depend upon whether it is movement only in X, Y, Z. If it is it's also moves in X, Y, Z in the 3-axis. If there is a 4th axis, the 4th axis can be a rotary axis. Rotary axis can be in it is rotating in around the x-axis, around the y-axis, around the z-axis, depend upon the machine construction. And this axis also can be, the rotation can happen on the workpiece, also the rotation can happen in the tool head. So that all differentiation are there. And also there is 5-axis, where in 5-axis there is 3 linear and 2 rotary axis available. Then another one is that based on the motors, whether it is a stepper and servo, those stepper have the property extremely reliable and less maintenance for the stepper motors. That is some of the advantage, and not so some other disadvantage, not so accurate as servo. It is not so accurate as servo, and this performance of this motor is depend upon speed, and at low speed high torque but choppy, and when high speed it becomes smoother but the torque is very less. So this is the characteristics of stepper motor. And in a servo you can see very accurate and smooth, and resulting in final resolution of final product, fine resolution of final product. And it's a little expensive and require more maintenance in the servo motors as well. This is the axis motors, with the movement of the machine done with the axis motors. The stepper and servo is coming in that category. Then the other differentiation is that by drive system driven, the movement happening, there is a transmission is there now. So how it is happening? It is the mechanism is ball screw, or it is a lead screw, or rack and pinion. In ball screw driven with the ball bearings, so the best drive system and more expensive. In lead screw, the screw without ball bearings, then it's a cheaper but low cut quality due to backlash and when motor change direction. Then this one is rack and pinion, and the third one is rack and pinion. You have the straight or bevel teeth on that, and it is much cheaper but low cut quality due to backlash when motor change direction. So this is the another way of categorizing it. Then also we can categorize according to the work holding system, how you are holding the material. So you can have vacuum table or you can T-slot table according to the CNC router machine. So in vacuum table you can have a section hold down material and easy to change the workpiece. Here the plus point is that you can easy to change the workpiece, and suitable for panel wood or sheet where machining time is less. We have to frequently change the material. Then this is the best way of doing it. In T-slot, the clamping type and take more time to fix the job. It is suitable for solid wood or can where machining time is more. Then the other one is based on spindle, that is the main cutting motor. In that spindle also we have 3 types of according to the cooling systems. Based on the type of cooling, we have water cooled, air cooled and self cooled, and also based on the tool, whether it is a manual tool changing or automatic tool changing, and according to the power supply it can be single phase or 3 phase. This is the different way of categorizing the CNC router machine. Now we will see the main part of main supplementing item is that of this the cutting tool, because the quality of cutting tool and the geometry of the cutting tool is very important for the getting the final result. So many shapes and size tools are available. They should be sharp at all time to maintain high accuracy, So then only we will get the good finish. Different materials are there for the tools, carbide tips as well as the diamond tipped and abrasive type. And carbon tips are inexpensive and wear out quickly, but diamond tipped abrasives are expensive and last longer, and can also be able to service 4 to 8 times before replaced. So it has a life also, much higher life, more life is there for the router bits. Then we will see about what are the maintenance and safety. So power safe, maintain machine use more power. So power when turned it on, shut it off regularly. So just leave it on throughout the day. So if you don't have work also, you can put it on and keep it, because every time you start the machine it sucks more power. You keep it on, and it just leave it on throughout the day. There is no problem. It can wear out motors if we on and off too frequently. That also one of the you can in the power side is concerned. And the cleanness, you have to keep the machine very clean, can save a lot of money on repairs. So the cleaning is very important. And safety, protect your body from machine, especially hands, eyes and ears. And when handling machine, wear gloves, eye and ear protection. So this is the some few points about the maintenance and safety of the machine. And the another part, as a conclusion, CNC router is an automatic machine and can be used for shaping different kinds of materials for numerous applications like door carving, signage, jewelry making, interior, exterior, pattern making, nameplate marking, etc. It can increase the creativity, productivity and profitability if you know how to use the machine properly. Thank you very much for listening to me, and having right kind of knowledge with this kind of machine is very important when you are going to invest in CNC router machine. If you want to invest in a CNC router machine, if you want to take a conscious decision whether this investment is going to work for me, and later if you want to make multiple streams of revenue from CNC router machine, I have created a course and it will be launching very soon. I will be before that I will be conducting a webinar to get into the more details of the course and how it is going to help you. Below there is a link. You can click the link and register for the webinar. You may also subscribe if you feel good about this content. You can subscribe on my channel so that you will get more related information whenever I post this kind of content in various social medias. Thank you very much.